Hello and welcome to Lecture 4 of Phil 10, Critical Thinking, here at Penn State Berks. My name is Dr. Stephen Bujno, and this lecture is on logical relations, modal concepts, and equivocation. It's going to be a little longer than the other ones, not because I think the material is necessarily more difficult, but by me utilizing more slides and illustrations on the screen, I think it's going to be easier to understand as I walk through it, so rather than try to jam it all into one slide. So when we're talking about logical relations, we're establishing the truth values without researching the state of affairs of a particular proposition. This is the benefit. So we can't be an expert in everything, but sometimes just by determining what is the relationship between various propositional statements, we can make an assumption or a very clear possibility, or even literally call that the conclusion is true based on the relationship it has to the previous statements. So in this sense, one truth value of a proposition is going to depend on the truth value of other propositions. So without even knowing exactly what the truth value is of other propositions, by us knowing one of them, we might be able to figure out exactly whether or not the other ones really make sense in the argument. So if we're going to say, here's an example, the moon is bright and it is nighttime, we're going to say that's consistent because we can imagine the moon shining at night. Now, it's best when we walk through some of these scenarios to not overthink things and try to come up with some weird scenario where that's possible. These are illustrative, so they're just meant to show the point, not to try to be taken apart and to see if there's some exclusivity that does not exist. So the moon is bright and it's nighttime is a consistent relation between the moon being bright and it being nighttime. If we were to say there is a rainbow and it is nighttime, we're going to say there's something contradictory there because we know that it's going to take more light than what reflects off of the moon in order to go through the water droplets and such and create a rainbow. Now what's nice about determining logical relations is that they come first in the sense of a hierarchy over what we may hold as attitudes or what we have known as beliefs or opinions. Now, what is interesting about this is oftentimes we get stuck into a dichotomy where we think that we have only two choices between things, so we only see two sides to something. This relationality is going to show us that that doesn't really hold, and it gets rid of that cliche, which often gets in the way of us having a reasonable argument and discussion. So we have different truth values here. We have the truth value of the propositions. We have what we assent to as far as the attitude, and then the actual state of affairs. So is the door open, or do I think the door is open? And before I explain a little bit about exactly those three items there, let me just say that what is good about understanding this consistency and contradictory logical relations is that it can really rein in whatever justification we might have for holding a particular attitude. So everybody has an opinion. Some opinions perhaps are better than others. Some attitudes just don't work regardless. In other words, a belief is not going to stand regardless of how strongly you hold it or passionately you hold it if there's something wrong in the relationality of the propositions within the argument. So back to this. If we look at truth in the way that we could say a proposition has truth, we could say that the proposition is capable of bearing the truth. If we say that our attitude, our beliefs are true, we're talking about in a sense of how we hold that particular truth towards whatever it is, the proposition. The state of affairs makes it true. So we want to be clear that when we say what I believe is true, the truth value of the propositions is true, or the state of affairs is true, we're not really using truth in the same way because we cannot by the nature of each of those. So let's just make sure that as we move through here and we put truth value into propositions, that proposition itself is bearing the truth, and the state of affairs is the actuality of it. Whether or not we hold that particular thing to be true is a psychological attitude towards it. Now, there's a few different logical relations that I'm going to show, and the first one here is logical inconsistency. So what this basically means is it's not possible for all propositions within the series of statements to be true. So if we're going to say the moon is bright and the moon is not bright. We could say that that's contradictory because it's not possible for both those propositions, the moon is bright, and that's one proposition, and the moon is not bright, for both of those things both to be true or false. So we could say all SSP, all subjects are the predicate, or some subjects are not the predicate. To put this into a particular common language, we could say all questions are stupid, or some questions are not stupid. Both of those cannot be true in the same way at the same time. If we say that no, let's say subject is the predicate, or some subject is the predicate, putting it into common language, we could say no questions are stupid, or some questions are stupid. Those are contradictory statements. Now, it often becomes confusing when these show up in common language, exactly what is contradicting what. So once again, I want to bring up the square of opposition here, and we'll come back to that in a second. So the difference between a contradictory, where it's not possible for both P's to be true or both false, and a contrary, not both P's could be true, but it is possible that both prepositions could be false. Now, it's easy when you see it in plain language. We could say all politicians are crook and no politicians are crooks. If we're going to say all politicians are crooks, then the only way to refute that, or the contrary, is to say that no politicians are crooks. But a contradictory, what we could do with a contradictory is all we need to do to refute that is to basically show that some of that particular group may fall underneath or outside of that group, we should say. So rather than say no SSP, let's say nothing is new under the sun. No things which are new are those which were under the sun. If somebody's making the argument to say nothing is new under the sun, you don't have to show that all things are new under the sun. That's the contrary. All you have to do is show the contradictory, that some things new are under the sun. The minute that you show some, then none cannot hold. So it's just a way to understand the difference between contradictory and contrary statements. And if somebody's making a statement, all you need to show is the contradictory of it to refute exactly what it is that they are saying. Okay. Now, let's look at some of the definitions of logic relations. When we find something logically wrong with the relation of any proposition, and this is regardless of the actual truth value to that proposition. Now, I gave you one already, the logical consistency, as far as a logical relation. Here's another one, a tautology. Now, there's tautologies that we're going to use here in logic, but it's also tautologies in grammar. So not to confuse you, but let me give you a tautology in grammar so that you know exactly what I'm saying. If I were to say all unmarried men are bachelors, I'm saying the same thing. The definition of an unmarried man is a bachelor, and the definition of a bachelor is an unmarried man. So in logic, all we're saying is P is necessarily true, and it's not possible for P to be false. So it's almost like you're saying the same thing. So the moon is either visible or it is not visible. Now this is not a false dichotomy because only one of those two things can actually be. But this isn't about the state of affairs. This isn't about, whether the door is actually open. So I want you to keep that in mind. This is only about the logical consistency as far as relations are speaking. So we're not trying to determine whether or not the door is actually open, but we just know logically the door cannot, be open and not be open in both of those ways. So tautology is just telling us that whatever we're saying, it's necessarily true, and it's not possible for that thing to be false. If you deny a tautology, then the proposition itself is logically inconsistent. An example here would be all humans die. Okay, now maybe you would understand this as, well, that's obvious. But this is a tautology because there's something within the nature of the human person that makes us mortal. So mortality is a necessary aspect of the nature of the human person. So when we say to die, it's already assumed within the human person. In other words, you can think of it this way. There's nothing new being brought by to die. If you talk about the nature of a human, it's already part of it. A third relation is logical consistency. So this is if and only if all the propositions can possibly be true. So you can think of things in a series, and then you just ask yourself, are these things, let's say, contingently related? I'll show you that in a second. But are they possibly be true? So if we're going to say it's nighttime, the moon is shining, and it's visible, we know that all those things are possible, right? We know it's possible to be nighttime. We know it's possible the moon is shining. And we also know possible that the shining moon at night is visible to us. We would say those are contingently related because the state of affairs themselves have some relation, and in a sense, one truth does not really depend on the other. We could take out the fact that the moon is shining, and we could still say it's nighttime, and the moon's visible. It may not be shining, but it's visible, and such. So another easier example, I would say, is that I was conceived, I am living, and one day I will die. All those things are contingently related. They're the state of affairs, but one doesn't necessarily depend on the other. They're just simply all possibly true as determinative state of affairs. The fourth one is logical implication. So if implying P is possibly true, then implied P is true. If it is nighttime, then the moon is shining. Well, it's nighttime. Okay, so if we're going to take if it is nighttime as what we are implying, and the moon is shining as it is what's implied, then the minute we say it's nighttime, it just will then the implication will flow from what we imply. What we're saying here, though, is when we say implies, we're talking about a logical implication. All right, so it's nighttime. It becomes a consequence of, well, I should say it backwards. The moon is shining becomes a consequence of it being nighttime. Now, interestingly enough here, these, if we talk in terms of features, these things are asymmetrical. So if it's nighttime, the moon might be shining, but if we just say the moon is shining, it doesn't necessarily mean that it's nighttime. And the relational, they call it reflexive relationality in this idea that it implies one implies the other. And this is also transitive in the sense that we could have a string of these. And it works that if A implies B and B implies C, then logically A, where we started with, as a proposition, will imply the final proposition C. An example would be, our logic class meets on Thursdays. We have class today, so it's Thursday. Now, we couldn't do that symmetrically backwards. In other words, we couldn't just say, well, it's Thursday, hey, we have class, because it could be like on Thanksgiving, which is on a Thursday, we're not going to have class. So if we have class and we only meet on Thursdays and we're meeting, we know it's Thursday. But just because it's Thursday doesn't mean that we're meeting. So the logical implication there is not symmetrical. A fifth one is logical equivalence. Now, it's not possible for proposition 1 to be true and proposition 2 to be false. So if we're together in class on Zoom, well, then you have a computer. Even your phone's a computer. So again, don't overthink this. We could say that only living beings die, and that's a tautology. It's not possible for one to be false and the other to be true. If you're taking a course on critical thinking, you know more than before. Now, that's a safe statement to make. You might think, well, I don't feel like I know more, but you obviously know more than before you started taking the course, so it's not possible for knowing more than before to be false if you're taking this particular critical thinking and logic course. The knowing more after is simply assumed. You're going to take the course, you're going to know more. Now, modal logic has to do a little more specifically with exactly the relationship between the various propositions. And it asks, in essence, in what manner. That's what modal means, like the modality, the manner of something. How does it actually have that truth value? So our choices here is that something could be actually true or it could be actually false. It could be possibly true or it could be possibly false. It could be necessarily true or it could be necessarily false and contingently true, and it could be contingently false. So we're going to look roughly, well, a few of these anyway. Let's start out with modal concepts and logical relations. So is it possible for a set of propositions all to be true? Is it possible for a tautology to be false? So logical relations determine the modality. So it's not possible for a tautology, to be false. It says the same thing. All unmarried men are bachelors. It cannot be false. There's something that is necessarily true to that. So that necessity of truth is the modality upon which that tautology stands. Is it possible for a set of propositions to all be true? Well, yes, because then if the argument's valid, we have a valid and sound argument. So without these modal concepts, we really cannot form any sort of sensible argument to help us in our discussions, right? Let's say it that way. So let's look at this. If we're going to talk about a valid argument, okay, so this is all the premises are true, and it's not possible for the conclusion to be false. Okay, in an invalid argument, it is possible that the premises are true, but it's also possible for the conclusion to be false. Those two things have to be true in order for us to be able to reason through these things. So what we're looking at here is, do you see the relation there? One is not possible and the other is possible. So you can look up ahead and say possibly true or possibly false. And both of those statements under an invalid argument and the valid argument, they are by necessity true. If they weren't by necessity true, then we couldn't count on them as logical laws. So if they all wind up being true, we will then say that they are actually true and they are sound. So little by little, we're trying to get into one of the modalities and how the relations are. So I have here an old logician's joke that I'm going to use to break down and show you how these modalities all work. So 3 logicians walk into a bar. The barman says, "Does everybody want a drink?" The first logician says, "I don't know." The second logician says, "I don't know." What does the third logician say? Now, in the first and second proposition, when they say "I don't know," it's because at this point the truth is only possible. In other words, there's not enough information yet to know exactly, but there's still a possibility for it to happen. If the third person says yes, then that becomes the actual truth. In other words, does everyone want a drink? The third person will say yes, and then we now know, just by relation, that the first one and the second one also got a drink. Let me explain this. The reason why the first logician said he didn't know is because he had no idea what was the second and third logician were going to say. So he couldn't say we all want a drink. He can only speak for himself. The second logician still could not know, because even though he may have known what the first logician had to say as an answer, and he knew what he had to say as an answer, he had no idea what the third logician was going to say. So if the third logician heard the first logician say, "Yes, I want a drink," and the second one, "Yes, I want a drink," he knows he wants to drink, so now he can say the answer to the question, "Does everybody want a drink?" Yes. It becomes actual. So the third, we would say, again, we're just looking at the relations here. The third is contingent on both the first and the second proposition. If the first two said yes and the third wants a drink, then the person who says yes, it's necessary then that holds because of the first two. Now, if that still seems a little confusing, I got a grid for you. It's actually one in your book, but I put it together here too. Now, this is just a logical joke, but if you really think about it, this is a series of propositions. And if we can never know really the truth value of proposition 1 and 2, but we know the truth value of proposition 3, it's going to give us knowledge as to the truth values of the previous 2 propositions. All right. Now, the implications of all of this. Here's the grid. Our choices are it's possibly true or it's impossible. And then if it's possibly true, it could be necessarily true, contingent, or contingently false. If it's impossible, it's necessarily false. If it's necessarily true or contingently true, it still has the capability of being actually true. If it's contingently false and necessarily false, it will be actually false. So, in essence, when we say, "Does everybody want a drink?" at that point, it's possibly true that everybody wants a drink. When somebody says, I don't know, the first two logicians, at that point, it's contingently true or contingently false because they don't know what will follow after them. Once the third person, answers yes, we now know it's actually true. So just by the value of that, we're able to determine the first two. Now, this can be applied in a lot of different arguments, but I hope at least that visual helped a little bit making sense of it. So there are types of possibilities and impossibilities. We have moral possibility, technical possibility, natural possibility, and logical possibility. And you can see there, the moral possibilities determine what we ought to do. Technical, what's our actual practical capabilities? Can we do this? Natural, well, there's going to be some causal thing that's determined by laws of nature. But all we're concerned about here is the logical possibility or impossibility. So we're only applying logical rules per se. But they're all determined by a constraint. You cannot be asked to morally do something that is technically or naturally or logically impossible to do, right? So it could be that, some poor fella drives his car off of a bridge and sinks to the bottom of a river. Do we have a moral, is the moral possibility of removing that? If we don't have the technical way to do it, and because of the flow of the waters, there's no natural way to do it, then the moral depends on the technical, natural, and logical. It seems pretty straightforward, but I just wanted to lay it out for you. Okay, last slide. And these are a little easier, fallacies of equivocation. Now we're back to the first act of the mind in a sense, right? So we said at the beginning of this course that there are qualities of terms. It could be exact, vague, unambiguous, ambiguous, clear, or unclear. We want our terms to be exact, unambiguous, and clear. Because otherwise, we will just create confusion in what the meaning of these particular terms are. Now, in relational logic, this is not just true for the term, but it's also true for the syntax. In other words, the way that the particular sentence is laid out. So we're going to look at 4 different types of fallacies here. If we look at a fallacy of ambiguity, this is a valid argument but with ambiguous terms. So if I were to say love is all you need in life, eating pizza is love, then eating pizza is all you need in life. Now that's a valid argument, but obviously we're not using love in the same way here. So there's something that's ambiguous in this particular term. Fallacy of amphibole, the validity effect is affected by the terms of different grammatical functions. So if I were to say, I defended myself from a robber with my gun, we're not quite sure exactly who are we talking about with my gun. This is a misplaced modifier. In other words, did I use my gun to defend myself from the robber, or did the robber have my gun? And did I have to defend myself from the robber who had my gun? If somebody were to say, like a politician, I will not support raising taxes which hurt the poor, we're not quite sure what they mean by that. In other words, they're phrasing it in a way that they have a bunch of wiggle room. If we put a comma there, I will not support raising taxes which hit the poor, then all they're saying is anytime you raise taxes, it's going to hurt the poor. If we move the comma over a little bit, then we're not going to support any taxes that only hurt the poor. In other words, it gets a little difficult to exactly figure out what they're referring to. So leaving out the comma can allow for 2 different interpretations, and that would be the fallacy of amphibole. The fallacy of composition and division are, mirror images of each other. So composition is determining the feature of the parts by the whole. It says if you study real hard, you'll have the highest score. Okay, well then what if everybody studies hard? Will they all have the highest score? So this idea of study real hard, this is something that's specific, and if we apply it to the general, it no longer works. So it's if you study real hard, you'll get the highest score, but if everybody does it, obviously not everybody's going to have the highest score. This comes up a lot of times in economics. I tweaked it a little bit here so that it made more sense for us. But somebody might say in a bad economy, it's good for businesses to lay off employees. Now, I don't mean it's good for the employees, but it's good for the health of the business to reduce costs and such. But in a bad economy, it is good for a country to have less employment. So do you see there's something there as far as, to lay off or to have less, just because it worked for something specific doesn't mean we could apply to the whole. And the fallacy of division is just the exact opposite of this, where we're determining the features of the whole by the particular parts. this one I think is pretty obvious once that you see the argument. Anyone who has a PhD must be very intelligent. Sally has a PhD. I'm sorry, it's misspelled. She must be very intelligent. So you can't go just from the general and then go down to the specific and expect that particular relation to hold. Here's another one. And you could put whatever group you want in and whatever particular type of power that you're thinking of. But if somebody were to say people who belong to group A have more power than those who belong to group B, and then you meet somebody, Freddie belongs to group A, therefore has more power than anybody in group B. Just because we have a general statement doesn't mean we can find somebody within that particular part and then say that they too hold for this. There's a lot of different ways you can apply this. But I just wanted to give a quick run through. This is something that's obviously we'll follow up in class and be able to answer specific questions. But I hope that this at least put a little bit meat on the bones for what you had to look at in the textbook. Thanks for listening.